So guys, it's Simon Fiaz, and today's video is on aqueous chemistry level carboxylic acids and derivatives question paper. Which statement about this is correct? Aqueous solution can react with magnesium to form carbon dioxide. React with magnesium to form carbon dioxide. No, it can form hydrogen bonds. Yes, it can. Electron diffusion, hydrogen atom can bond to an NOF atom. Which compound is formed when phenylbenzene carboxylate is hydrolyzed under acidic conditions? Under acidic conditions, so what we're going to form, phenylbenzene carboxylate. So we want to form a carboxylic acid. So therefore the answer must be D. Just how well you know these reactions and all that mechanism stuff. Any reactions and equations. Question 3 is question about esters including biodiesel. Esters formed by the reaction of acid and hydride. Acid and hydride, which is made from two identical carboxylic acid molecules with an alcohol. Complete the equation. Okay. I'm going to form CH3, CH2, C double bond O, O, CH2, CH3, plus CH3, CH2, COOH. Name of the ester. The ester, so this. Let's draw it out fully. So I've got O, CH2, CH3. Now remember when we're naming esters, it's made up of two parts. The first part comes from the alcohol. The second part comes from the other bit. So the first part comes from the alcohol, which is this one. Methyl ether. And I guess no, second bit comes from the carboxylic acid, but in this case carboxylic. So that's an ethyl group. In this case, methyl ether, but it's got another carb, so it's going to be propyl. Not propyl. It would be propanoic acid, but obviously because this doesn't have the OH, it's going to be propanoate. So the name of the ester is going to be ethyl propanoate. It's not propanoic ethyl, which I could see even myself falling for it, because just propanate and ethyl. But remember, when naming ethyl, it's reversed to the formula, so it's ethyl propanoate. Part B, draw the structure of vegetable oil showing clearly the ester links. In reaction with biodiesel, 1 mole of this vegetable oil reacts with excellent methanol to form 2 moles of ester with molecular formula of that, and 1 mole of ester with molecular formula of that. Represent the hydrocarbon change in the form CXHY, X and Y, the actual numbers of carbon and hydrogen atoms. O, clearly the ester links. C17H31 HCO C double bond O C17H31 H2CO C double bond O C17H33. Perfect. And it says part C, complete the skeletal formula show the next part of the hydrocarbon. Carbon atom number 14. Number 14. So I need okay, so it's going to look something like this. Here, 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 here. 8, 9, 10, 11, 12, 13, 14. Perfect. Double bond here. Double bond. there. Give an equation for the complete combustion of the ester. Okay, so remember, complete combustion, enough oxygen to show products of purely carbon dioxide and water. So it's just going to be C19H34O2 plus oxygen to form CO2 plus H2O. I've also got 19 carbon on the left hand side, so I need 19 here. I've got 34 hydrogens on the left hand side, I need a 17 here. And now I just need to balance the thingies, so it should be 26.5 here, 26.5. C19H34O2 plus 26.5O2 to form 19CO2 plus 17H2O. Part E, state how the infrared spectrum of carbon dioxide above is not what you might predict from data provided in table A in the data booklet. Well, the absorption here is around about what? 1, 2, 3, 4, 5. So that's around about 2,350. So what I'd have to say is that absorption in the spectrum at 2,350 centimeters to power minus 1 does not correspond to data booklet value of 1680 to 1750 centimeters to power minus 1 for the COO double bond. Explain how carbon dioxide causes global warming. And this question literally just shows you that you need to know everything for your chemistry exam. Yes, they like to repeat certain topics, but they can always, focus on specific topics that are just a lot of them memory based, and if you haven't gone through it because you thought it wouldn't come up and it does come up, then you're in a bit of trouble. So how carbon dioxide causes global warming? C double bond O bond CO2 absorb infrared radiation, IR radiation emitted by the Earth does not escape from the atmosphere. Which compounds formed by acid hydrolysis of that phenyl methyl ethanoate? It's going to be an alcohol, so it's going to be A. Give the equation for the reaction of this with AlCl3 to form the electrophile. So I've got, obviously I already know the mechanism name, but first, does it ask me to name the mechanism? No, it just says outline a mechanism. Or it tells me the mechanism, electrophilic substitution, yeah. So AlCl3 plus CH3 CH2 COCl, I'm going to form AlCl4 minus. I already know that. That's just your knowledge of how I know these equations. So what else am I going to form? I'm going to form CH3 CH2, and this Cl's gone here, so I've only got C double bond O left. Bond to carbon, C double bond O, and remember this carbon is positively charged, carbocation. And again, that just comes from how well you know your content. Then it says outline the mechanism of this electrophile with benzene. So, which electrophile? COCH2CH3. Because that is the electrophile. Remember, the AlCl3 is a catalyst. So, benzene. The benzene should be able to draw that pretty nicely. Obviously, that's not a really nice structure. A diagram I've just drawn. Then I've got my CO. I don't really show the double bond in this case. COCH2CH3. Carbon's positively charged, and it's going to go from a ring of delocalized electrons to the carbon. And then what happens? is now I've got something like this, and I've got a partial horseshoe ring. That's how I remember. I've got a positive charge here, and I've also got a hydrogen bonded to this, and I've got the COCH2CH3. 2CH3 from here to here. Is that it? I think that's it. How many marks is that? 4 marks. Obviously that's probably going to be 1, and then the remaining going to be 3. That's a lot of marks. But basic mechanism. Obviously this is a bit complicated because you've got unusual thingies, and you need part A really to understand what you're forming, and then reacting with the electrophile to react with it. Ring of the electron to the carbon with positive charge. There, rid of the H to there. That's it. Part B, give that UPAC name of the alcohol. Group the reagent needed for this reaction, name the mechanism. So organic product in part A. Organic product in part A. Okay, so it's going to the IUPAC name of the alcohol. Methane, ethane, pro. It's going to be 1 phenol, because I've got the phenol group. Propan dash 1O. Got the phenol group attached to the first carbon. Propan, because methane, ethane, propane, and then a carbon. Oxygen bonded to this carbon as well. So 1 phenol, propan, 1O. Reagent needed for the reaction, name the mechanism. It's going to be NaBH4 or lithium aluminium hydride. Any of those two. And the name of the mechanism, nucleophilic addition. Describe what we observe when alcohol reacts with ethanol chloride. Ethanol chloride. Well, I'm going to form an ester, so could say misty fumes, or I could say a fruity smell or a sweet smell. Name of the mechanism when the alcohol reacts with ethanol chloride, nucleophilic addition, elimination. The structure of the ester. So you would just have to, I guess, go through the whole reaction, because the alcohol reacts with ethanol chloride, part B. So yeah, I would just go through the whole mechanism, and you should get the ester as CH3, C double bond O, CH, 1 that phenol, CH2, CH3. Four-step synthesis of compound T is shown. Give the reagent and conditions for step 1. For step 1, I'm going from. What am I going from? I'm going from. This has got a carbonyl group, and then I'm going to. Well, this is obviously an ester to an alcohol. So I'm going to use sodium hydroxide, aqueous, and how you could obtain a sample from the reaction. fractional distillation. Draw the structure of compound S. Now compound S is when I go from this to this, and then from this to the NH2 group. So compound S is going to look like, yeah, because remember nitriles can be reduced to the aromatic amine, so it's got to be a nitrile that I'm going to react with. So it's going to be CH3C. Yeah, so all it's going to be is, yeah, this is compound S, CH3 CH CN CH2 CH3. What I'm doing is it's nucleophilic substitution. I'm just replacing the bromo group with a CN group, and this is a classic reason why you need to know your synthetic roots of organic compounds and of all the other compounds. And I'm going to be going through those. I did upload a video today as well. I'm going to be going through them quite often. Then question, oh, it says for each of steps 3 and 4 give a region and one condition other than heat. Okay, so step 3, step 4, give a region and one condition. That's going to be 2 marks each. So C, again, you need to know your conditions and all that. So step 3, well, the region is obviously going to be KCN with the CN group nitrile. And remember, it's alcoholic or aqueous, KCN, alcoholic. Step 4, it's going to be, now going from hydrogen, I'm going to use step 4, hydrogen and nickel. Catalytic hydrogenation. And that is it for this. I'm going to continue this in another video. I'm just not feeling quite well.